Hello students, we will now look at the second experiment, which is namely the specific resistance by meter bridge method. If you remember, we had done the first experiment, which was specific resistance of the wire by ammeter voltmeter method. Now remember, whatever value you have got in the first experiment to the dimensions of 10 power minus 7 ohm meters, you should approximately get the same value in this experiment also, because you will be using the same wire of which to determine the specific resistance of. Before we do that, we will first look at what do you mean by a meter bridge. Now, if you look at it, the meter bridge looks something like this. Okay, it looks something like this, and it's called as a meter bridge because it's got this wire, the length of which from this end till this particular end is exactly 1 meter. That's why it's called as a meter bridge. This is called as a meter bridge. Okay. Now, bridge, because it works on the principle of Wheatstone's network. I will deal in details when we come to the oral questions part of the experiment. Now let's look at what circuit diagram would you be required to follow for this particular experiment. The circuit diagram for this experiment is, as you see here, this is that wire which I was speaking of earlier. This thing is complete the meter bridge. This is the first gap, which is this gap here. This one is the second gap, which is the second gap between this. This one is a middle terminal to which you have to connect the galvanometer. So this one is the middle terminal. Now in between these two, you connect the unknown resistance. In between these two, you connect the known resistance in form of a resistance box. You have a plug key here. You have the battery eliminator or source of voltage, and you have the rheostat. This is the variable terminal of the rheostat, which goes to one end of the meter bridge, and through the key it goes to the other end of the meter bridge, and the connections can be as seen in this particular diagram. Now once we make the connections, I will tell you what all do you require apparatus to finish off this experiment. So you require one unknown resistance, that is a wire whose specific resistance is to be found out. The idea is what? First you measure the resistance of the given wire. With the help of that resistance, you can then go on to measure the specific resistance. You already have a resistance box. You need a galvanometer, and this is the jockey which you require to move it over the wire. You require one plug key. You require a battery eliminator, and you require a rheostat. This would quite be possible that you may get a little confused between the meter bridge and the potentiometer. So this potentiometer we'll talk when we take up the experiment on potentiometer. Remember, a layman's rule, meter bridge consists of only one wire, whereas potentiometer will consist of 4 wire. Fine. So your identification for a thumb rule, for a layman's rule, is meter bridge 1 wire, potentiometer 4 wire. Okay, before we start the actual circuit connections, it's always a very good practice for all the experiments having a circuit diagram to keep the apparatus as they appear in the circuit diagram, so that will ease up your connections. Now here there's the wire. I've kept the wire here, the galvanometer over there, the resistor box over here, the rheostat with a variable terminal facing this end. You have the battery eliminator. The position of this can be on the other side as well, but then you'll have to take 2 wires from underneath the meter bridge to connect it over here. The plug key here for the ease with connection over there. Okay, now let's look at the actual connections. So this is the wire whose resistance is to be found out, and hence the specific resistance of the wire is to be found out. This is the galvanometer. The positive end is connected to the middle terminal and the negative end has gone to the jockey. Please remember, whenever you do a connection, please take a long enough wire for the jockey because it has to move from this end to the other end. So make it a point to keep the wire long for the jockey. Take 2 short wires for the resistance boxes because they are at shorter distances. This is the rheostat. The variable terminal has come to the end B. The lower terminal has gone to the negative of the battery box or the eliminator. From the positive, it's come to the key. From the key, it has come to the other end. Now, this works on the principle of a Wheatstone's network. You've got 1 arm, 2 arm, and wherever you keep the jockey and you get the null point, you get the third and the fourth arm. Now, how do you first start? Always ensure that the galvanometer should show deflections on either side. That's when the connection is complete, and that is the indication that the current is flowing well through both the arms of the galvanometer. So now